We continue to look at the questions in our exercise on change of variables in partial derivatives. This question here, z is equal to x to the 5 plus y to the 6 minus e to the x cos y. You must find the partial derivative of z with respect to t when x is equal to t and y is equal to 2t squared. Now, as usual, know that a change in z is equal to the partial derivative of z with respect to x times a change in x plus the partial derivative of z with respect to y times a small change in y. That's a formula that you must carry around in your head, right? You're looking at a change in y being the rate at which it changes with respect to z multiplied by, so how fast is it changing with z? How fast is it changing with x? Multiplied by the number of x's, or how long x is. For example, the amount of money you're earning per hour. The amount of money that changes, the amount of money you get in addition to what you had before is the amount of money you get per hour multiplied by the number of hours, which is the change in hours, right? That's one thing you can relate it to. Very important formula. Alright, now let's take everything. Let's say z is changing with respect to time, so it's changing z divided by a change in time. You have divided by a change in time here and divided by a change in time here. Now, as the limit of delta t tends to 0, then you have delta partial of z with respect to t is equal to partial of z with respect to x times the partial of x with respect to t plus partial of z with respect to y times the partial of y with respect to t. Alright? So you need to find each of them. What's the partial of z the partial of z with respect to x? So I'm looking at it here. It's 5x to the 4th minus e to the x y, e to the x cos y. Alright? What's the partial of z with respect to y? Well, it's going to be, when you work it out, 6y to the 5. Okay, when you differentiate cos, you get negative sign. Negative and negative is going to be a plus. It's going to be e to the x sine y. Alright? Now, I'm just going to separate this from the partials that we're finding. The partial of x with respect to t is 1. And the partial of y with respect to t is going to be 2 2's 4t. So these are the 4 partial derivatives that we found. So we substitute them here now. So what we have? Partial of z with respect to t is equal to alright, so just going to do something there. So the partial of z with respect to t is equal to, so what we have, partial of z with respect to x, which is 5x to the 4th minus e to the x cos y. That will be multiplied by the partial of x with respect to t, which is 1, plus partial of z with respect to y is 6y to the 5th minus e to the x sine y times partial of y with respect to t, which is 4t. Alright? If we choose to multiply out the brackets, to expand the brackets, we have 5x to the fourth minus e to the x cos y plus 4, 6, 24 y to the 5t minus 4t e to the x sine y. So that's what we have there.